So, okay, you see it?
Yeah.
Perfect.
Share it full screen, please.
Yes. Here we go. Which also means, though, that as long as I'm looking at the screen, I don't see the Zoom anymore because I only have one screen here.
Okay. Yeah.
So, yeah, just for you to know.
You can choose a side-by-side view, by the way, in screen sharing.
Really?
Then, yeah, you should do that because then you see yourself or us. And
where is this option?
Up on the right part, there's something for at least for me. And now I can see it because it tells me it's view on the right, well, upper right corner of the Zoom window.
View. Well, now that I'm sharing, I don't have it anymore. I don't have view.
Well,
I don't
it's
have
somewhere, but you have, yeah, it's always hard
I
to
have
find
it as a presenter. Sorry, as a attendee, I do have this possibility to exit full screen mode, but not as a presenter.
Yeah, maybe you're right. You're right. Yeah, that's correct. Now I remember. When you're presenting, actually, you don't have that choice.
Yeah, like if I open the chat now, you see.
We are already live now, so this is already going out to YouTube.
Okay. Hello, YouTube. Sorry for this. Do we have all the panelists then? Can we really start?
Yeah, Sandrine and Raphael are here as well.
And Alexia as well?
No.
No, Alexis, it's not yet.
Yeah, sorry, yeah, I forgot him. Well, anyway, should probably start.
Yeah, well, I guess I can start anyway with, Alexis is here, he raised the hand. I guess we just need to make him a co-host. Okay.
Okay, I will.
Sorry for this part, this is what goes on behind the scenes. That's because we are live and yeah, that's the beauty of it, of being live. So, I'm Francesca Vitalini, and I'm a senior solution consultant at Mirai Solutions. And today I'm here to moderate the panel, Are User or Are Developer? This is the question, and it's actually really a question because since I started talking about this with my colleagues and in my network, I realized there is really no consensus of what these two roles are in the community. What type of skills should an R developer have versus an R user, or what type of backgrounds is it involved? So I realized it's really important for us to have an open conversation about this. And today we are going to do it with 5 different experts of our community that I'm really happy to host here today. So we have here, I'm going to read a tiny bit of a biography, sorry. So we have Martin, who is a professor of statistics at the mathematics department of ETH. And it's he was one of the pioneers of the R language and is currently part of the R development team and the R Foundation for the R project. Then we have Alexis Laguer, who is head of analytics and technology department at Partnery. And he has expertise in the reinsurance business, but also bridging the gap between commercial, actuarial, and analytic teams. We have Nick Crane, who is a data scientist and a software developer with expertise in production-grade code and training. And she has experience in developing both R packages and Shiny applications, as well as NLP models in Python. Then we have Sandrine Dudois. I hope I'm pronouncing the surname correctly. My French is terrible. Anyhow, she's a professor and the chair of the Department of Statistics and professor of the Division of Biostatistics at the University of California, Berkeley, with a research focus in development of statistical methods and software for biomedical and genomic data. She's also a founding core developer of the Bioconductor project, together with our last but not least panelist, Raphael Irizzari, who is also a professor of applied statistics at Harvard and chair of the Department of Data Science at Dana-Farber Cancer Institute, and is also a developer of open source software and for the implementation of statistical methodology and part of the bioconductor project since the very beginning. So I'm very happy to have you all here, as well as our audience. And I would also like to thank our sponsors. I was loosely coupled with the organizing committee of user 2021, especially in the sponsoring section. So I really know how important it is to have people supporting us. So I'm going to say thank you for the sponsor of the day, which is our studio. Now, with no further ado, because we only have 1 hour, I would like to dig in and start with the first real question, which is what is the definition of an R developer, and how does it distinguish itself from being an R user? And I would like to ask all our panelists to give a little bit of their own perspective, also based on their different background. So why don't you start, Martin? Martin, you're muted.
Hello, everybody. I have the perspective of, yes, of an R core member, but also of an academic who teaches math and stats and computational stats and things like that. And as many of you know, R is really, in some sense, the daughter or son of S. And John Chambers is the guy who mostly devised the S system. And he got the very famous computer science award, the ACM award, which is only given to one person once a year for creating S. And he wrote the book, that's now the topic. He wrote the book with the title, Programming with Data Using R or Using S. And so his approach is good data analysis, good statistics, good data science, whatever you want to do it, good machine learning means programming. You cannot do good data analysis if you just click buttons and choose from menus or so. So you have to do programming and creating S, and from there R really provided tools to use high-level programming languages that doesn't need a computer science education, that doesn't need compilers and so on, as you all know, to do data analysis that is adapted to your data situation, to the problem you want to solve. And so in this sense, I think all good data analysts, data scientists should be programmers using R. And in that wide sense, all such good data analysts are developers, because some people told me, well, a developer is somebody who programs, who writes code. And in this sense, good data analysts writes R code, even writes R functions to make his whole analysis somewhat reproducible, well documented, and so on. Yeah.
Nick, do you agree with Martin's perspective?
Yeah, absolutely. So I definitely agree with the idea that, you know, it's quite a wide thing that we could probably call a lot of people an R developer. I think this question also is something that we really need to be careful about the context that we're asking it in, because we're at a real risk of potentially sounding quite gatekeepery. So at a kind of high level, absolutely, you know, an R developer is somebody that writes R code. I might even put something in there about a little bit of knowledge of software engineering principles, even something as simple as writing functions or even including documentation. But then it gets more complicated, I guess, if we're thinking about that distinction in the context of the job market, right? Because I think a lot of the time, an R developer and a data scientist can be very similar, but there's more distinction between data scientists and Python developers, say, than data scientists and R developer. And I think it gets a bit more complicated when you get to that point.
Yes, thank you very much. And Alexis, what is your perspective from an industry point of view?
So there's a difference between people who use R and use that to fit models, who are clearly writing code, and what I would call an R developer. For me, an R developer, and distinct from R core developer, which is something else, but an R developer is someone who applies software engineering principles to build production code and environments and happens to use R to do so. And that makes it rare because R is not a particularly well-known computer science type language in comparison to, say, Python. But in the right context and in the right organization, and we've recently hired our own R developer, where we say there are reasons why we want to build production software in R. And it's not about fitting models, and it's not about data science actually, and it's not about ML or anything like that. It's about build R code, which is production ready, which can be deployed, which is reproducible, which is scalable. Use techniques from software engineering to make sure it will be maintainable and robust also for your colleagues to work with. And when you do that, you are, in our context, an R developer.
Thank you, Alexis. And Sandrine, what about academia? Is it the same there?
Hi, everyone, and thanks, Francesca, for putting together the panel. So what's an R developer? That's not such an easy question. And I think that's one that we could ask for other languages as well. And it's clear already from talking to different panelists that there are different perspectives in academia or in industry, or even within academia and industry. I think I'll step back a little bit. So there's really a range of expertise in our users, from someone that just uses the software for the first time to someone that advances the language and makes research level contributions to computing. So I think an R developer is somewhere on that spectrum. The real difficulty is where you put the boundary, and also what features of that person you use to define that boundary. So for instance, you could put a developer as someone that contributes a package to a repository like CRAN or Bioconductor, or someone that produces production level software. But then I think there's a real big difference between someone like me who contributes packages, and then say an R core developer like Martin, who advances the field of statistical computing. So I often use this analogy from math. So there's a big difference between someone that uses a theorem, applies a theorem in a very useful manner, and then someone that actually proves that theorem. So I do think it's worth adding maybe a third category to reflect at least 3 levels, that cover the whole spectrum. So beginner, intermediate, and advanced. So I think the real question is define the variables or the features of that would define these different types of R users or developers, and try to come up with an understanding. So I really look forward to hearing more about this.
Thank you. And last but not least, Raphael, what do you think? Do you agree with this 3-category model, or you have a different opinion?
Yeah, I mostly agree with what Sandrine, the Sandrine explained. Also, my definition is similar to Alexis. So the first thing I thought about when you invited me to participate in this panel is, why are we defining this? What's the point of defining this term? And the one reason I can come up with, and it's something that actually is somewhat important to me, is for hiring people. So if I'm going to use that term to hire people, I want it to mean something that everybody views has the same definition. That will make my life easier. That's a selfish goal, but let's take that goal as my goal for now. So with that goal in mind, I would define our developers similar to Alexis and Sandrine. I have 2 jobs. I am an academic that writes papers and tries to disseminate statistical methodology or computational algorithms that I come up with, or my students and postdocs. And I'm also the chair of a data science department in a cancer center, where we actually develop production code for making decisions for patient care. Those are different, very different, but at the end, the R part is similar. So in the case of an academic, if I come up with an idea that I arrive at, as Martin described, programming with data in R, and I want to share this idea with the world, want others to use it, to implement it. I want it to be fast, efficient, well documented. So I have become too busy to do that myself. So I want to hire someone to do it for me now, or for my postdocs and students, wherever else. And there's also the other reason too, is because there's people out there that do it much, much better than me. So I would define R developer as someone who could write efficient R code, know how to make packages, know how to document, know how to make it efficient, and by, for example, writing C++ code or using matrix algebra. And that's similar to the other side of my job, which is to implement production software. So in that sense, that's how I would define R developer. I also, when I first heard the topic of this panel, when I thought of R developer, this is before I had thought about it more after our conversations. The first thing that came to mind was someone that was making R, improving the R language. But since we have conversations, I now have a more practical definition of what an R developer is.
Yeah, that's great. I'm really happy that this panel is already bringing something useful, even if it started in less than 10 minutes ago. Anyhow, let me share my screen again. I would like to show you what has the community said so far. So quite interestingly, almost 50% of the people who took this survey, and we are talking about a really small amount of people, it was about 150 people who took the survey over the span of a week. Well, they thought that an R developer is someone who develops tools for others to use, and this can be also domain specific. Then 21% of believes that it's someone who structures the code as a package. 13% believes it's someone who extends the R language. 10% is someone who applies basic software development concepts to code designs, and the rest is other answers. And also in terms of defining an R developer versus an R user, we see quite a bit of a variety. We had this question both in the survey and in the LinkedIn poll that I ran for a couple of weeks. And then we saw in both cases quite a uniform distribution, slightly peaked towards the R user. But yeah, this is another sign for me that there isn't a clear definition or a clear understanding of what an R user is with respect to an R developer. Okay, so with this, I would like to go back to what Rafael said at the end of his answer, and it's about hiring. So first of all, Nick, what do you think is the concept of an R developer in the job market?
Yeah, so I guess as I was saying before, it's really can be hard to distinguish. So for example, I've had previous jobs where I've had the job title data scientist or data science consultant, but actually when you look at the work I've been doing, it has been mainly R development. So with that, it becomes difficult. And then there's so many different facets within R. Like, again, I've been an R developer. I've ended up doing web app development. I've ended up doing package development. I've ended up doing machine learning. So again, it's really hard to pin it down. Although with all of those things said, as somebody that doesn't come from a traditional computer science background, I think the things that have made me stand out from other candidates that I've been told have been useful when I've been applying for R-related jobs that have been more developer focused than say stats focused have been things like knowledge of concepts like unit testing, version control, deployment, coding standards, and all those more kind of traditional software engineering type concepts. And I think that probably comes from the fact that traditionally, if we kind of divide data science into R and Python, a lot of our users will come from an academic background, which isn't necessarily computer science. And I think it's those bits and pieces that can make somebody stand out a bit more.
And I see you, Alexis, nodding there. So what do you look for when you hire an R developer, considering that you just hired one?
So I think what Nick just described is what I would call the carpentry of R development. So of any development, actually, unit testing, deployment, automation, mastery of your tools, and so on. And then for an advanced R developer, I would be looking for someone who can, I don't know, think in a computer science way. So here is an algorithm in code. Is this heavy on memory or on computation? What if your memory is constrained? How would you modify this? How do you do the trade-offs, which you would do in software engineering? How do you trade off speed versus memory? How do you understand that, or can you, if we go, okay, this is cool, but now we need to parallelize it, how would you do it effectively? And then linking that to, R has some really sneaky gotchas when you're trying to vectorize or turn something into matrices or so on. Do you understand these concepts, and do you understand how they apply to R? And do you understand how these trade-offs work so that you can develop something truly next level when asked to do so? And those are software development skills linked to knowledge of the R language. It's and for me, it's genuinely both. It is R, developer. I expect all these things of a developer, but if somebody has all these things and just knows it for Python or for C++ and doesn't know it for R, they will not be able to perform in this role because they don't necessarily know and understand how the underpinnings of R can help or hinder you as you're trying to solve these questions.
And Rafael, do you agree with Alexis? Do you think this is applicable in academia as well?
Absolutely, 100%. Both Nick and Alexis, they're basically summarizing what I think we need to explain when we write a job ad, and that's what I was referring to when I said I would hire them, not only because I don't have that much time anymore, but because they're much better than me at things like unit testing and other software engineering principles. So that's exactly right. I think that's how I would want to write an ad now to hire a software engineer, explaining all those things. It has to be R, because, and why does it have to be R? That's something else we haven't talked about. Like if all you want to do is share your statistical ideas, it could be done in Python or whatever else. But I think there's two reasons. One is because already the prototype will be done in R. And second, because the users that we're targeting are mostly R users. At least in my case. This maybe Python is close, but in the genomics world, it's about even right now. But yeah, I agree.
Okay, so maybe you can continue on this and tell us a little bit what type of skills practically should this person have? Like, should they know DevOps, version control, or which ones would be the most important for you? And maybe Alexis, you can follow up there with what would be most important in your case.
Oh, sorry, did you ask that one to me, Francesca, first? Oh, sorry.
No, I didn't. But if you have an opinion on that, please.
No, I thought you said Nick, but you didn't, so I don't need. Yeah,
no, I was asking Rafael to continue on that.
Of course,
but yeah, feel free to.
Well, I don't want to be repetitive. A lot of the concepts and skills have already been described. The one that I would add for my own area is we don't always get this, and you can learn it on the job. But if you get someone that already knows the details and the nuances of the biological problem or technological or the technology that's generating the data, that is a huge plus. It saves us a lot of time in training them. And of course, I imagine that's similar to other application areas. But other than that, I think between Nick and Alexis, they kind of mentioned everything I would put on the list.
Yeah. I would add one, I'll call it a non-technical skill. It's a behavioral skill, empathy with the end user. Sort of it's if you're technically amazing, but either the end users don't want to talk to you, or you don't understand what they're actually after, and you don't build what is actually needed, then you are not as valuable as you could be to the success of the organization you're in.
And Martin, maybe what would be, in your opinion, the top skill that an R developer should have? Unmute yourself, please.
I'm used to teaching, there I'm never muted, sorry. Rafi made a very important remark. There are some skills that you can learn on the job, and you should learn because it's inside the company you work, they have their standards anyway. And so I think it's well, of course, I have the point of view, I want to teach people to be creative and thorough and self-critical data analysts. And that's something that needs much more time than to learn a new style or to learn a new dialect of C or whatever. So the question is really, and I see that there's in the Q&A, somebody actually asked the question too. Now, most our users, and that's probably still true, come from statistical data science background and not from computer science. At least that's very much the case in Europe. I don't know how much it's on the West Coast or in California now that things change. And of course, in industry, there are computer scientists too that come to use R. But I still think the data analysis skill, which is not just a pipeline of things you run your data through and then you get the output, is something that needs time to be taught. And we still emphasize to teach that to our students and not computer science skills, because then if they go to computer science, that's fine. And machine learning is actually at our institute, machine learning is taught by both statistics and computer science, with an emphasis on computer science, whereas then there are other fields.
So can I comment on something? I agree with everything that Martin is saying, but I would agree to it when describing a data analyst, which I consider to be a separate task than a software developer. And in academia, at least the academia I've experienced, we have good academics that are good at data analysis, and we teach it. And it's hard to teach, like Martin says, it takes time. You have to there's a lot of critical thinking, but we're not, at least in my experience, we're not that great at software engineering. There are good ones out there. There's, R core and the people developing tidyverse and data table. They're great software engineers, but I don't think that's the majority in academia. We tend to not be trained. And also we don't have, the incentives are in place to make you spend more time performing data analysis and developing methods, either of the two, depending how applied you are. So there's not that many rewards, in my opinion, unfortunately, for people who spend a lot of time making their software very efficient, very user-friendly. And that's why we're trying now we're trying to, because there's no incentives from the academia side, we're trying to use grant funding or other funding to hire people that are really, really good at that and let them do that part, given that it's hard for me to tell a postdoc or a graduate student, spend the next 6 months making the software really, really good, as opposed to telling them write another paper. It's not really my decision, right? That's just the incentive structure that's in place right now. We're all trying to make it, to reward more for people who actually take the time to, but it hasn't quite happened yet.
Thanks for this point, because it really brings me to say something. So forward in my list of questions, there was one about the way we teach R, and I would like to ask Sandrine if we shouldn't start to include some computer science elements in the way we teach R already, considering that normally the R user or the R practitioner is someone that is maybe coming from a very domain-specific background and not computer science.
Right, definitely. And I just want to say that I echo what Martin and Rafa have just said about the qualities that we're looking in. It's in the self-criticism is key, common sense is key. And then Rafael mentioned this idea of incentive system. I mean, there's been a lot of resistance in academia about spending time, not just on statistical computing, but even applied statistics. So I think we really need to change that and start including these in the curriculum. So you can learn by doing. That's one way, but at some point, I think you do also need some form of training to be able to have, general concepts about computing and more concepts from computer science to incorporate that in the statistics or data science curriculum. Before doing that, I think we have to think about what populations of students we want to train. It's not one size fits all. And then for each of these different populations, think about the learning objectives. So just from my own perspective, chairing a statistics department, we already have different populations of students. We have our non-majors who, we basically want to teach them a little bit of data literacy and computer literacy, but they will most likely not end up being developers. So that's a population we have to think what we want to impart to them. Then there's our graduate students. So for these students, we want to teach them more advanced notions about data analysis and in computing. And there's a real problem here in particular with data analysis is it doesn't scale up very well. If you really want to teach applied statistics or the practice of statistics or computing with data, you want to start with case studies, and it's a bit of an art, and here interaction is really important. It's not something you can just do passively, teaching to a huge audience, and it takes time and interaction. So I think identifying the different groups of students and learning objective would be a start, and just making it's a lot of communication around that and showing the value of teaching statistical computing to the academic community. It's not computer science, it's not statistics, it's sort of something that brings elements of both, and that will be evolving as data science is evolving nowadays.
I think it's very hard to teach good software engineering practice in the context of a data science program or a statistical program, because your constraint is time. And then, like both you and Raphael have said, incentive. Software engineering is a craft. It's something, you speak to software engineers and they'll tell you, and I know this from my own experience, the first language you learn is a language. The second language teaches you concepts. But by the time you've learned your fifth programming language, you're starting to understand software engineering and have seen the sort of deeper patterns. And teaching multiple software languages in parallel to an entire data science curriculum is both challenging time-wise. People only have so many hours in their semester. And incentive-wise, if I'm a data scientist, why would I learn these things when I think I'd probably better learn Bayesian methods of machine learning, because that makes me more marketable in the job market? So I think producing R developers straight out of university is really hard. R developer is the marriage of people using R, having experience, somehow melding those things together, a lot like Nick has described her journey. And then at some point you go, oh yeah, I've got both sets of skills. I can program in R and I know what it is. And that's how R developers are made. I think it's very hard to teach them.
So with this idea that the R developer can be a bit of a unicorn, but it's a necessary one to have production-ready code, then can we say that R is a language ready for production? And I would like to ask Nick to comment on this, because you have the experience of producing production-ready code.
Yeah, absolutely. So actually, when people express skepticism about this idea, it really frustrates me. I was in a job interview in about 2018 with a multinational consulting company, which I won't name, and they dismissed R as, oh, it's just something people use in academia and people don't use that in prod, which is utter nonsense. All it meant is they didn't know how to put it in production themselves, which is very different. There's so many tools out there. You've got things like you can make APIs with Plumber, web apps with Shiny, so many different things out there. So in terms of, R in production, there's so many examples as well. So I've worked on projects that have involved kind of making a massive Shiny app that can support hundreds of concurrent users that's now used in the NHS in the UK. I've worked on projects that involve writing packages and APIs that are used by the Office for National Statistics. So I find it completely ridiculous when people say R is not ready for production. And I think, as Mark Sellers said in, I think it was our studio conference 2019, it's cultural, not technical barriers that get in the way of R going into production. Ran over.
Completely agree.
Oh, I just realized we have questions in both the Q&A and the chat. Just so you know, in case you're looking.
Oh, Francesca, were you muted then?
I didn't want to mute people. I was trying to unmute myself. Anyway, what I wanted to say is that it's great that we have questions in the Q&A. I will reserve a little bit of time at the end of the moderation to take whatever the audience is interested in and ask it to all the panelists. But please, can you put the questions not in the chat, but in the Q&A? And you can also vote for questions in there so that we will take the most popular first. Thank you. back to the main point here, we were talking about R being a language for production, and I wanted to ask if being R a language that is very user-friendly makes it more a language ready for production, or more a language ready for POCs. And Alexis, what do you think about that?
In production is a definition, right? In production means, yeah, it's up and it's running and it can do certain stuff. And well-written code is easy to maintain in production. It's not just about getting it out there and it actually working. The easier your language is to use, generally, the easier it is to maintain, the easier it is to collaborate on a project, the easier it is to modularize pieces, the easier it is to possibly deploy into a more microservice architecture. R doesn't have a comp-sci background. It's, if you compare it to languages which have been built to be in production, you look at Rust, you look at Go, it's not there, but that doesn't mean it can't be used in production. C, sort of how much of the universe runs on C? C is a horrible language to put into production because it has no guardrails. There are so many security holes in the world's infrastructure because this was written in C by well-intentioned people and it didn't get the daylights tested out of it. So I don't think the user-friendliness of the language is a way to think about whether something can be put into production. It's about, is the core bug-free? If something goes wrong, can you find something? Do you have the tools available to modularize and to collaborate and to deploy automatically? And all of that is the case for R. Is it the right choice for every organization? No. But in an organization which has a lot of people in it who already use R as part of their daily work, it's a good choice, because that means if somebody's looking at an internal website and something's not working, they can go look at the source code and understand it, as opposed to this has been written in Lisp and good luck, because nobody else in the organization or the front end of the organization understands that language.
Nonetheless, R being an approachable language has clearly been one of its success factors, so that now is one of the most used programming languages. So I would like to ask Martin, what do you think is the reason, or one of the things that makes it really approachable?
Well, I know about 4 or 5 computer languages, but not many more. So I think we started teaching R to our students very early, or even students that are far away from computer science, even much further away than mathematicians are, for instance. And we never used the thing that is called, I forget, John Fox menu system. Anyway, we thought that it is easy enough. We started to say, okay, it's just like a pocket calculator, but that, of course, nowadays doesn't work anymore because people have their smartphones. They don't even know what a pocket calculator is. But yeah, still, I mean, you can start just by adding numbers, and it has a state and it is interactive. You don't need compilers. You don't. There are many things that you don't even have to learn about. And at the very beginning, you can work in the console. So that's the thing. You don't even have to learn about files and things. So that makes the entry part, of course, easy. And then compared to the proper computer language with a compiler and where you have to declare all variables and things like that, so it was written to be, I mean, it was written to be fast and good at, and also good at prototyping, yes, and quickly get from data to a graphic without much coding, and that was a genius thing to invent when they invented it in the 1980s, I think, or even started in the end of 1970s, when the only other computer language basically was Fortran, and then after a while there came C along. And so that was really a genial idea, is to say, okay, let's try something that is close to how we do formulas in math in some sense. It works vectorized. At that time, no other vectorized. Well, actually, there was APL for those of you who may know it. That was my first computer language, by the way, APL, when I was in gymnasium. Anyway, no, I mean, that made you can start using it. You get to a plot without having to learn about syntax, really. You can even just use visual pattern matching and you can get the plot graphic. And that's very rewarding to get people started, I think. And I'm really talking about non-computer scientists here.
And I think that strength is also its weakness.
Yes.
I mean, we've probably all heard the quote, the advantage of R, it was developed by statisticians, the disadvantage of R, it was developed by statisticians. You can get really far with R without ever seeing a function and knowing and ever writing your own one or so on. So you don't, most other programming languages, as you learn them, and most of the things you described, just Python has those as well. There's a command line, there's no compiler, it doesn't have typing, but that is a very well-structured comp-sci developed language. Guido von Rossum is a computer scientist who developed it. So when you learn Python, you very quickly learn about these paradigms of computer science. But it's not quite as accessible as R is. And you can get very far with R just using it to get stuff done without having to learn these software development paradigms. And that's why the fork, there've been a few questions in the Q&A, okay, I'm an R user, how do I become an R developer? You might have gone quite far down that road and that jump is now big because you're suddenly missing a whole lot of stuff underneath, which you never got taught, which you somehow need to backfill. Whereas other languages would never let you get that far without you having learned at least some of that along the way.
I agree with what you say, Alexis, but the fact is that many people would stop using R if they had to learn all these concepts.
It's an awesome language for that very reason, sort of, and it is so fit for purpose for just analyzing stuff. That's exactly the reason why. So within our organization, we have a lot of actuaries, people who know a lot of math, and we want to give them a tool to do more advanced analysis. Step away from Excel, please. R is obvious for that. It's so easy to get people going. But when it comes to, okay, now one of these folks has written something which is really nice and you want to industrialize it, you want to productionize it, you want to deploy it, you often need to take 15 steps back and rebuild it from behind to get those engineering principles in place. And that's fine. It makes it perfectly appropriate. But it does mean, and the same can happen to you in Python, no question. But it is one of the challenges when somebody goes, I'm an advanced R user, how do I become an R developer? There's a chasm. It's breachable. If you're an advanced R user, you definitely are going to have the potential to become an R developer, but there's a whole bunch of stuff you need to learn to move across.
Yeah.
And what is for you the most important characteristics of R that makes it so approachable?
Oh, that's a really great question. I guess there's certain things like the R community. So it's really easy to go out and get help on things. Like maybe, in the past I've tried to learn other languages and years ago I was a bit nervous about asking questions on Stack Overflow. It's a bit different now, but I'd be so hesitant about doing that. Whereas now I can go there, I can go to Twitter and there's so easily answers to my questions and nobody laughs at my questions being stupid, which I think really helps there.
Thanks. And Raphael, do you think that maybe tidyverse would help making R more approachable?
In my experience, it has. I find it easier to teach using tidyverse for the very simple things, and ggplot also. So yeah, that I think has helped. But I think this relates to what Alexis was saying, that if you, at least in my lab, eventually you're going to have to do matrix multiplication operations, and so you might get really far using tidyverse, and then at some point I'll say, oh, you can't use it anymore. You have to now learn linear algebra and do it this way. So yes, it does, absolutely. But I think the main reason why R is approachable is really what has been said by Martin and Alexis, that you can get to a plot really quick, and that, you can do that in different ways. Tidyverse ggplot is perhaps the one that's most intuitive to the general public, but even the R-based way isn't that bad, or whatever else is out there. It's very quick. It's just like I think that's why statisticians in academia, at least applied statisticians, is the main reason they have kept using R, even though Python might be a more better thought out language, or whatever you want to call it, because nobody beats R if what you want to do is explore data, which is the most important part of my work, is exploring data to motivate statistical methodology, to check statistical methodology, and to test out look for bugs. The main way I look for bugs is by plotting stuff, not by looking at the code. And really, I don't think there's a doubt that R is the best for that.
Yeah, I agree. But on the other hand, so Tidyverse seems to help for a new user to approach their language, but can it be a problem for another user that wants to become an R developer, maybe due to this non-standard evaluation? And I think, Martin, maybe you can comment on this?
Yeah, I don't really know. Coming back to Alexis as well, the chasm that he mentioned, I'm really trying, as soon as I get away from just introductory or teaching, that tell my students, if you want to become a good data analyst, even, you should write functions. You should get out of the habit of editing your R script, like instead of writing a function, calling it 3 times, they edit their scripts, right? And so it's not at all reproducible what they do, because they change this line and so that, I think that part of teaching can be done even to completely not computer science people, teaching them some discipline. I don't want to get spaghetti code script from you. That helps, and that discipline is more important than if you use the Tidyverse, or to be honest, I teach them the indexing like subsetting is very, very powerful in R, and it has some intricacies, but in some sense, thinking of logical vectors to do indexing is much more useful in my view than going with the Tidyverse. Very much, but I don't want to get into a fight there. But it's my history. I always found it quite intuitive. The indexing idea, the idea that indexing in R can help to double your data set, right? By just repeating the index. And there are many, many things you can do once you understood this is much more than just extracting one element from a matrix. It's much, much more powerful. And it's all logical. But anyway, so people disagree or
I agree with you. Let's take an analogy for a kitchen. Sort of people want to cook food. They can teach themselves. So you can figure out how to write R code. Maybe somebody helps you, or you read the instruction manuals on how to use the machines which can cut your fingers off, because you can then make more advanced meals, but you then need to be careful. And I think what you're doing is that teaching, and it's important. But then it comes, okay, you want to run a restaurant. You want to be the chef in a restaurant. It's not enough that you can cook good food. You also need to understand, okay, if you leave this standing for more than 3 hours, there's a risk of salmonella. There's a whole bunch of things which the cook in your home kitchen isn't even thinking about, which the restaurant chef is naturally doing because they have that additional training on top of it. And not everybody needs to be a restaurant chef. But if you want to be a chef in a restaurant, there are certain things you will want to be trained and have done and so on. And I'm absolutely saying that not everybody needs to be everywhere on the spectrum. You have people at home who cook amazing food, and that's awesome. And these are the tools which allow them to do that, and that they are free and open source. And thank you to you and everybody else who has helped sort of produce that building. And there is a certain group of people where we go, yeah, we want you to produce this industrially. Cool. Then you need to know certain industrial things. Awesome. And unfortunately, we don't have training courses for it at the moment. We just find people who figure it out themselves, and we try and help them get better at it.
Great. I think this is a really nice analogy. Now, for the sake of time, I would like to start looking at the questions in the Q&A. So I'm just going to start with the one that is on the top. I'm sorry, I didn't have the time to read them through before, so I'm going to read them out loud now. So there is a question from Alexander Courtois. Sorry if I mispronounced your name. Anyhow, the question is, as someone that started to learn computer science via R, I appreciate the narrow gap between the user and the developer. I started as a user, then started to code functions, then packages, then adding C++. I do feel, however, that the recent spread of packages built around non-standard evaluation, tidyverse, has widened this gap a lot. At the same time, it has generated many more users that may become developers. What is your view about such a gap between user and developers, and how to narrow it? So I guess this goes a little bit in the same direction of my question from before, but yeah, we'll be very happy to hear some of your thoughts. Anyone, maybe Nika, you want to?
Sure.
answer?
Yeah. So yeah, no, that's a really interesting question, and I also find it fascinating. Obviously, somebody talking about kind of getting C++ in there, and I'm like that. That is definitely developer level. I'm just starting that now. I think the non-standard evaluation one is a really interesting kind of example to look at, because I remember it was about 2018 early on when dplyr and kind of similar packages started using a lot of that stuff, and I really struggled with that at the start and could not wrap my head around it. And there's been so many resources that have come out since, breaking it down. There's now an Erlang cheat sheet, which I've used a lot on recent work. I can definitely see that perspective, that it could widen the gap. But I think there was a really good talk a few years ago by Jenny Bryan at one of the RStudio conferences about basically there's loads of circumstances in which you might think you need tidy eval, but you don't actually need to use it. And it's more just thinking about how you achieve what you're trying to achieve. So I think it can be challenging, it can be difficult in that gap, but I don't think that's necessarily a problem given the amount of power it can add to doing things.
Yeah. Then there's another question by some anonymous attendee who asks, accounting that many R users are not from a software engineering background, what would be the path from an R user to an R developer? And where and how would one R user learn to be an R developer? And maybe Sandrine, you can comment on this, considering that we spoke about teaching before.
Sure. So I mean, I think there's multiple paths. That's a really good question where that transition occurs. I think others have provided partial answers to this. So I think it's a combination of, you know, learning by doing, but also taking some workshops or courses, working with people that are more advanced than you are. I found that, to me, that's been a really effective way of learning. Looking at packages that are good quality packages, and learning by looking at the code for these packages and trying to implement some of the techniques that are used in these packages. So it's really a range of paths to become a developer, I think. And you have to, you know, a lot of it goes back to experience. I think I really want to emphasize that. Alexis mentioned it earlier. For software development as well as for applied statistics, a lot of it is an art. So you can learn some of it in a classroom or in a workshop, but then it's really doing it and experience and working with others as well. And I don't think there's a discrete point where you jump from being a user to a developer. It's a progression, and you'll become a more and more experienced at it. And the community, let me just go back again, the community, I think, is a great way for that. The forums, the mailing lists, the documentation. Yeah.
I think that was a really great point that Sandrine made about working with others, though, because one of the things that I found most useful for improving my R development skills is engaging in things like doing open source development, and therefore having code reviews, engaging in pair programming. You know, there's so many courses out there, there's so many things you can read, but actually having that one-on-one kind of experience, I found, has accelerated my skills the most.
I think also going back to what Sandrine said, that it's a bit of a progression. There is a spectrum between the R user and the R developer. There is this other question about is it possible for a person to be both? And is it preferred? Considering that here in this panel, we always talk talked about the two things as if they are distinguished, but is it even possible to be in certain projects an R user and in other projects an R developer? And I don't know, maybe Rafael, you can comment on this. I see you nodding.
Oh, I've definitely been both. Most of the time I'm an R user, but every once in a while I write a package, more before than now, but then I become an R developer, I guess. I'm thinking about how to make the package efficient and user friendly exclusively once I figured out what I want to do statistically. But to figure out what I wanted to do statistically, I did a lot of R using. I mean, I think in academia especially, you're going to have a lot of people that do both. But as it has been mentioned throughout, the day has 24 hours, so it's going to be, there are people that are very talented and they can be very, very good at both things. But in general, you know, the better you get at one, the less time you have for getting good at the other. And that's where I'm hoping that there could be, at least in academia, but I think also in industry. I mean, the cancer center I work at is more similar to industry sometimes than academia, where that will be also true. That we can have a division of labor that makes the whole operation more efficient, where you have in each task someone that's really, really good at it, and they're working in the same environment, so there's enough communication that it won't suffer from the fact that it's two people doing it together as opposed to, you know, just one person.
I think it might be a bit of a tadpole question. When does the tadpole become the frog? And when does it stop being a tadpole? I've not yet found anybody who went and trained to become an R developer. Just like we've interviewed people for data engineering positions, and there we look for R as well. They started using R to do the analysis, and over time they found their own interests drove them to more, I'm really much more interested in building tools for other people than doing the actual analysis. So I will sharpen that skill set. And then one day they go, oh, here's an R developer role. I fit that perfectly. And it's not actually asking for PhD level data science. It's just asking that I can build stuff in R. I can do that. So there is, I think you can be both, no question. I think a specialist is likely to be better than the average, unless you find that unicorn at the development, if they've focused some time on getting good at the development part.
Thank you. I guess we can move on to the next question from Arnold Decker, which is a bit of a different point. So he asks, so in his experience, a scientist needs to know well R, but as a statistician, it is very important to have good communication skills to really discover what is the need by the scientists in the field. So for example, environment or nutrition. Can you comment on this? I don't know, maybe Alexis, you also mentioned this emotional intelligence before.
So that's, I used the word empathy earlier, and that's exactly what I mean. Again, it's a thing when you have the larger your team is, the more you are able to go, yeah, here's somebody with a very tight skill set and nobody talks to them because they're a bad communicator, but the team can absorb it. Given how we've spoken about how our developers are rare and you're likely to be only one in an organization, you absolutely need to be good at especially the listening part of communication, hearing what the other person wants, then feeding back, this is what actually can be done. This is what we can commit to in the development, feeding back, and then ultimately delivering. That is a communication skill.
So for the sake of having communication empathy here, maybe we should clarify something for Yazan Adad, who asks what skills are required to jump from advanced to developer, I guess advanced user. And it mentions, I was thinking about R Inferno, but that's just internal. Does deployment production mean knowing other languages? Or are you simply talking about the customer perspective? So maybe here we should clarify the concept of production, and maybe Nick, you can comment on this.
Yeah, that's quite a difficult one to pin down. There are lots of different things talked about there. There were some ideas about, do you need to know other languages as well? And I'd say not necessarily, although there are certain skills like knowing a little bit of bash, a little bit of command line that can be useful. But then again, there's some fantastic packages now, like Use This, which in combination with Action, you can kind of automatically set up continuous integration for a package on GitHub straight from R. So whilst those other skills can be useful, I wouldn't say they're as necessary as they might have been a while ago. And sorry, I've forgotten what the rest of the question was.
It was about, do you need to know other languages or it's just a customer perspective?
So I guess, was this the question that also talked about moving from an R user to an R developer as well?
Yeah, I guess it was a bit of two questions in one.
Yeah, I mean, I don't think that the languages are necessary, but that's because I don't see that much distinction between an R user and an R developer, really. I just see it in terms of, having a few of those software development skills at a minimum. So that's kind of, hard to say with that one.
Mm-hmm. Maybe because look, at the time we just have one more minute, so I would like to close with one question that is about the future. So are we expecting to have more support for R in production in future years? And maybe Martin, you can answer on this one. Unmute first.
Questions about the future are always hard, as we know as statisticians. I'm not sure, as we mentioned implicitly, if it's needed at all, because Nick was making a point. R can be used in many places in production, and other places maybe not. Yesterday I was at the Use R talk where somebody presented Kafkaesque, which is a package to kind of interface to Kafka, which is kind of this high bandwidth message passing. I didn't understand everything, but anyway, I think R is also very much an interface between systems and can be used at that. But then if you have very high throughput situations, I think that then the computer scientists need their very specialized software tools, and R is not the good tool. The idea of S, that John Chambers made that point also all the time. The idea is not that you use this language for everything. Use it for what it's really good, and that's quite a lot. And then you should also know its limit, where you really want to go. Like if you get satellite data, gigabytes per minute, or even if it's just per half hour, maybe you shouldn't try to do the front to that system in R, but rather in a very dedicated system. So I think production always means several systems working together. In the end, it's the web browser that almost all users interface with more and more, right? And production means you produce the contents of a web page. But that's not everything, right? In astronomy, you have to collect your data, or in particle sciences at CERN, also in Switzerland, as you know. I mean, they need different tools because they even process data when it's generated. They have to aggregate the data when it's generated from their particle physics. So they cannot, they need very, very special software for that, even very special hardware. So it's, production, as Alexis also said, the production can be very, very different things.
Okay, so by looking at the clock, our time is unfortunately up. I would like, first of all, to thank you all panelists for being here and taking the time to discuss this topic with us. I see we have still many questions in the Q&A, and I would like to invite you all to join the Slack channel and continue the discussion there. I will also share the other results from our survey, which I didn't share live because the conversation was just so nice. I didn't want to interrupt. So I guess this one is a wrap, and thank you all again, and continue enjoying Use R. I think the next one in the schedule is a mix. No, it's a keynote, or is it a mix event? I'm not sure. Do we have a slide with what's coming up next? Otherwise, I will quickly look it up. Okay, so up next in the schedule today is the MixR event. So yes, so we have time to network and chat. So thank you once again, everyone. And hope to see you soon.
Thanks.
Bye, everyone. Thanks.
Bye.
Bye.
Thanks.
Goodbye.